Hey everyone, welcome to our last video on quadratics from this series. Now finally in this video we're going to take a bit of a jump into something a little bit trickier, and this is the idea of factorizing non-monic trinomials. I mentioned this in the last video, but non-monic just means when the coefficient in front of x squared, this a, is a number other than 1. Now this actually causes us a lot more problems than you may think. Now if we consider something like this, we could try and go, okay, well, like PSF, let's see what happens there. My product is 3, my sum is 7. What are my factors? Well, you may already be looking at this and going, well, this is actually impossible because I can't think of any numbers that multiply to give me 3 and add to give me 7. In fact, the only numbers that do multiply to give me 3 are 1 and 3, and they clearly add up to 4. So this number plays a pretty big role in messing us up with our regular ways of approaching this. Now, what I'm going to do here is I'm going to give you a couple of questions, and for the first two I'm going to do it through playing around a little bit with some numbers. I'm still going to do the grouping in pairs thing we did in the last video, but for the first two examples I'm going to see if we observe any patterns once again, and once we figure that out we're going to use that to work through the third one in a lot easier of a way because we know what we're looking for. But to start off, we're just going to play around with this a little bit. So what I want to do here, because we saw PSF doesn't work, but what I'll try to do is I'm going to still try to keep breaking this thing here into a couple of like terms like we did in the previous video. And what that's going to do, eventually I'm going to get to a place where I can factorize something really nicely. Now for each of the two examples, I'm going to do it wrong the first time, and then I'm going to mess around and eventually end up getting it. Now, what if I broke up this 7x into 4x and 3x, and then tried to factorize by grouping in pairs? Well, I would take this as a pair, and then the other one as a pair too. So trying to group this one into pairs, I'd get 2x outside of x plus 2. So I've just taken 2x as a common factor, and I'm going to take 3 out as a common factor here, and I get x plus 3. And I can see here I'm at a standstill because I don't have the same binomial factor. So I've done something wrong. This means that the numbers I've chosen as my factors are wrong. So let's try this again. Let's try two numbers instead. Two different numbers here. Now let me try, for example, 6 and just 1 here. I could have written it as x or just 1. Let me try factorizing this now. So I've got here my first pair. I'm going to take out 2x as a common factor. What I'm left with is x plus 3. And here I can take 1 out as a common factor of both. Remember, I can take 1 out as a factor of any number when I don't have any other commonalities between here and here. And what I'll get in this bracket is x plus 3. So what I have done is now I've successfully figured this out. Now once again, I'm really just doing trial and error to look for patterns, right? If you're a bit lost and you're thinking, well, how did he know to pick 6 and 1? I didn't. I have to play around with some things first in order to get something that works. I'm still trying to group in pairs, but I'm really just freestyling it now to see if I can find any patterns. But now that I have found a common binomial factor, I can take that out the front. So I have x plus 3. And what do I get left with my other bracket? Well, I've pulled x plus 3 out as a common factor. Now for my next one, I will get 2x plus 1. Now you can see that even the answer in factorized form is a little different to what we had before. Look at this 2x, for example. In our monic ones, we only ever had something looking like this. But the simple inclusion of this thing here affects what we end up with, and it's going to affect the factors that we choose. So expanding this, just to double check I've done it right, x times 2x gives me 2x squared, x times 1 gives me x, 3 times 2x gives me 6x, 3 times 1 gives me 3. And taking the like terms, I'm going to wind up with 7x when I add those two together. So I get my thing up here. But that's still not really what I don't know enough to apply this to some other things just yet. So let's pause on this answer and try another question. And I'm going to once again try to freestyle this and see if we find any sort of commonalities here and any patterns that we can use to try to apply, I should say, to another question. Now let's say I have 10x squared. Let's say I have 10x squared plus 9x minus 9. Okay, I'll try that same trick as before. That kind of worked, but let's say, for example, here, let's do 10x minus x and then minus 9. So I've broken up this 9x into this and this, just to try to freestyle some factorization, see what, if anything, works. Now here, I'm going to pull out 10x as a common factor, and I'm going to have x plus 1. And here I'm going to pull out -1 as a factor, and I get x plus 9. We can see, once again, this is clearly not right because we don't have a common thing here. Let me try another way, see if that works. And this, for me, when I was doing this, trying to freestyle it, there were a bunch of different ways we could go about this. But the things we chose, and what you'll notice is, especially what I chose here, for example, this 6, I had to pick something that worked really well with this 2 when I factorize. So I'm not just picking these numbers out of thin air, I'm trying to find ones that work, but it ends up being a lot more trouble when we have this non-monic thing happening. So what if I try another one? What if I say, what if I take 10x and I go, let's say, I don't know, minus 5x plus 14x. Those two things still add up to give me 9x. Let's see if that works now. Now I'm going to maybe factorize, because I have even numbers here. Let me try to factorize these two. And let's see what I end up with. I can try it with either, but let's say I took 10x squared plus 14x. I rearranged my grouping a little bit, and I'll try this. Now, 2x is a common factor in this first pair, so I'm going to get 5x plus 7. Now I'm kind of a bit closer because I have 5x, I have 5x, but you'll see that when I say take out a -1 here, I have 5x plus 9. So I'm a little bit off still this one here is not the same as this. So I'm kind of struggling right now, right? There's not a lot that I can do. I'm going to try one more, right? What if, for example, I said, okay, I was pretty close, so why don't I just change this -5 to a -6, and I change this thing here to a positive 15. Okay, now what am I going to do here? Well, let me try grouping the two pairs separately. So I'll do this one first. So I'm going to do 2x as a common factor, because that goes into both 10x squared and -6x. And I'm going to take 5x here minus 3. I factorize my first pair. And now in my second pair, I have another case where I have a common factor to both of these terms. So I'm going to go 3 here outside of, and I'm going to get 5x and minus 3. So what I've done here is now I have found a binomial factor to both of these. That's really good now, because I can do what we've been doing so far. I can pull that out as a common factor. And remember, I'm still freestyling here. I'm trying to find a pattern. So once I factor 5x minus 3 out the front, I wind up with 2x plus 3. And voila, I have my answer. Now you can double check this one if you'd like, but this thing here is going to be the correct factorization. But now I'm kind of left scratching my head, right? Because I still haven't found a pattern. I've got two factors, but they're not factors that multiply to give me -9. But remember, the factors that we chose before, when we ended up multiplying these numbers, they gave us something in relation to the remaining values. It was just slightly different. But what if I try to mess around with this a little bit? I said that, okay, -6 and 15 are my factors. Now they add to give me this middle term, but what do they multiply to give me? So let me try multiplying -6 and 15. Now when I multiply these two numbers, this gives me -90. Now that's a little different from -9, but look at something curious and peculiar that happens here. Can I make this -90 out of anything else here? Well, -90 is the product of my first coefficient a and my last coefficient -9. So that's kind of interesting. So my product here, if I were to do PSF, my product was no longer my C, the last, this, if I have, you know, ax squared plus bx plus c, my product is no longer the c, my product is a times c, which is -6 times 15, which is -90. My sum is still the middle term, b, this 9x. My sum's still b. And then, which is, sorry, going to be 9. And now, instead of finding two factors that multiply to give me -9 and add to give me 9, I'm instead finding two factors that multiply to give me -90 and add to give me 9. Okay, that could just be a coincidence. Let's look at the top example where I freestyled it again. If I, to give myself some more space first, let's look at these factors that I picked. 6 and 1. They still added to give me 7. That's good. But do they, this thing that they multiply to, so if I add the factors, I get 7. If I multiply these, I get 6. Okay, so my product, I already know my factors. So my factors are 6 and 1. And they added to give me 7. And the product here is the same as if I were to multiply 2 by 3. It's the same as the second example that I did. The product was still my coefficient A times the coefficient C, which is 2 times 3, which is 6. And my factors multiply to give me the product of A and C. That is a pattern that happens in both of my examples. Now here, for example, the factors were -6 and +15. Two numbers that multiply to give me 90, the product of A and C, and add to give me B, the coefficient of the coefficient 9 before the X. So that's something that I can take with me for the next question and see if this works. So now we know that to factorize, and we're going to try this again to confirm it, to factorize non-monic, QT for quadratic trinomials, we can still use PSF, and we're finding the product, the sum, and then the factors, but the product is my coefficient A times my constant C at the end. And the sum is my coefficient B for all quadratic trinomials, which are in the form ax squared plus bx plus c. So now instead of finding a product that's this number and a sum that's this number, my product is the product of A times C, and my sum is going to be the B. Let's apply this to another question, our final question from this video, and see if this works. Because this is something we observed through playing around and trial and error, and it's given us something that we're going to try to apply to another question. We're using the pattern once again. So let's apply this to the question 6x squared minus 17x plus 12. So my product, I want something that multiplies to two factors that multiply to give me the value of 6 times 12, which is 72. And we want a sum that is equal to -17. So we want two numbers for our factors that multiply to give me 72, which is a positive number, and add to give me -17, this negative number. So I'm looking for two negative factors. Now, if I write out some factors of 72, I can have negative 72, negative 1. I can have negative 36, negative 2. I can have negative 8 and negative 9. And I can also have 6 and, negative 6 and negative 12. Okay, so I can rule out this one here, this one as well as this one, because if I do negative 72 minus 1, that gives me minus 73. That's definitely not negative 17. Same with negative 36 and negative 2. Same with 6 and negative 12, because those give me negative 18. But if we do minus 8 minus 9, that gives me minus 17. So those are my factors here, minus 8 and minus 9. So now that I know this, I can just write this out. I can break up my negative 17 into minus 8x minus 9x. So I'm going to go 6x squared minus 8x minus 9x plus 12. Okay, so now I can group the pairs. I'll group this one, I'll group this one, and it becomes the same as everything we've been doing up until now. So common factor of 6x squared and negative 8 is going to be 2x. So that gives me 3x minus 4. And if I pull out a common factor from the other pair, let's take out negative 3. That's going to give me 3x minus 4. Because these two negatives are going to make positive 12, and the negative and the positive 3 are going to give me negative 9. So now I have a binomial factor in both of my expressions, which I can then take out the front, 3x minus 4, and my next one goes into this first expression 2x times and the other one 3 times. And this is my answer. Let's actually just do one more question, because I know this is a tricky concept, and I'll give you another chance to practice with me a question now that we know this rule, this pattern that we established before, where our product is going to be A times C instead of just C, like with the monic ones. Now let's go with one more question. We're going to do 3x squared plus 2x minus 5. So what I want to do here is bring that to the middle. I have the product, the sum, and the factors. So my product now is going to be A times C instead of just C. So that's going to be negative 15. My sum is going to be 2. What are my factors going to be? Well, I want two numbers that multiply to give me negative 15 and add to give me positive 2. So I'm going to have this positive negative sort of pairing here. So if I have minus 15, my factors, I can have negative 15, positive 1, or positive 15, negative 1. I can also have positive 3, negative 5, and positive 5, negative 3. These two top two are clearly going to be wrong, because that gives me negative 14 or 14, which is different to this 2. And we can observe the same thing. Because this is a positive 2, then the number with a higher magnitude, the factor with the higher magnitude, is going to be the positive one. So I'm going to pick this one down here, because 5 minus 3 gives me 2, as opposed to 3 minus 5, which gives me negative 2. So my factors are going to be 5, negative 3. Now I can break this down. So I can break down my middle term, 2x, into 5x minus 3. So I'll have here 3x squared plus 5x minus 3x minus 5. So the order here, because we've picked the right factors, this will always factorize nicely. So the grouping in pairs, we can do it one of two ways like we've done before, but I'm just going to pick this particular one here. Doesn't really matter. You could have also picked 3x squared and negative 3, 5x and negative 5, but you're going to wind up at the same answer. So 3x squared plus 5x, the common factor here is x, and then we get left with 3x plus 5, and I can pull out negative 1 as a factor here to make these signs positive. I get 3x plus 5. Now I have a common factor, common binomial factor, which I can pull out the front. I get 3x plus 5, and in my remaining bracket, I'm going to get x here and negative 1. So that's how we can start thinking about factorizing these non-monic quadratic trinomials. Thank you so much for joining me, and I'll see you in the next video.